Yikes. That looks awful. I wonder if there's a way we can make that a little easier. Matter of fact, there is. So stick around and we'll talk about how. So when we have extremely large numbers like this one, and extremely small numbers like this one, there's something we can use that's called scientific notation. When we convert a number to scientific notation, we're going to have a coefficient, in other words, a number from 1 to 10, basically, multiplied by a power of 10. This n represents the power that we'll use. So, let me show you how we convert these numbers to scientific notation, and maybe that'll help. We start by thinking about where the decimal is on each number. Now, for this large number, let's just imagine the decimal is right here at the end. So, we're going to move the decimal over enough places to where we have it just before the 6. Why? Because the coefficient in our scientific notation needs to be between 1 and 10. So we don't make it 60, we don't make it 0.6, we say 6. Like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So for our scientific notation, our n factor would be 23. Our coefficient would be 6.02. 6.02 times 10 to the 23rd. Does that sound familiar? If it does, that's because that's the number associated with 1 mole of any substance. A mole of eggs would be 6.02 times 10 to the 23rd. A mole of pennies would be 6.02 times 10 to the 23rd. By the way, if we had that many eggs, or really that many pennies, we would probably all be dead, crushed under the massive amount of eggs and pennies that there are on the earth. Not a good way to go. Now, let's take a look at this second number. It's an extremely small number, and let's see how many places we need to go in order to get the decimal right here. Why? Well, we want our coefficient to be a value between 1 and 10. So not 0.2, not 20, but 2. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So now we have again a value of 23, but whereas this one was a very large number, this is a positive exponent, 10 to the 23rd, a very large number. This one is a very small number. We're going the opposite direction, so we have the opposite sign. So this would be 10 to the negative 23rd. And what's our coefficient? Well, in this case, it's 2. 2 times 10 to the negative 23rd. So the scientific notation of this number is 6.02 times 10 to the 23rd. And the scientific notation for this number is 2 times 10 to the negative 23rd. Get it? Let's try a couple more. Let's start with this first number, 582,000. The first thing we need to do is we'll place our decimal at the end here. Next, we'll decide how many places it takes to get that decimal to this point right here. Why? Because remember, our coefficient needs to be between 1 and 10. Not 0.5, not 58, between 1 and 10. So in this case, 5.8. So our coefficient is going to be 5.82. You see? I'll write that down. 5.82 times 10 to the something. Let's find out how much. We're going to go to the left 5 places. 1, 2, 3, 4, 5. Since we went to the left 5 places, that means we have 10 to the 5th power. Okay? So, anytime that decimal has to be taken to the left, your exponent goes up. Anytime your decimal needs to go to the right, your exponent goes down. Left up, right down. Left up, right down. Let's try the other one. 0.000000349. First of all, what's our coefficient need to be? 3.49. Good. 3.49. We know it's going to be multiplied by 10 to an exponent. We got to figure out what that exponent is. Here's our decimal. Which way are we going? To the right. So our coefficient is going to go down, isn't it? 1, 2, 3, 4, 5, 6, 7. So that makes it 3.49 times 10 to the negative 7th power. You get it? And that's how we do scientific notation. Now we need to talk about some rules that we use for our mathematical operations when we're in scientific notation. Addition, subtraction, multiplication, division. Okay? So let's do it with this problem right here. Let's start by talking about addition. 5.42 times 10 to the 6th, and adding to that 4.48 times 10 to the 4th. How do we add those together while they're in scientific notation? Now I tell you this, in order for us to add these two together, these exponents have to be alike. It'd be sort of like adding apples and oranges instead of apples and apples, if we didn't. So we need to convert one of these to be like the other one. How do we do that? What I like to do is change the one that's smaller to be like the one that's bigger. Let me show you what I mean. First, I'm going to keep this larger one the same. 5.42 times 10 to the 6th power. Now I'm going to change this lower one to be like this one. But how many decimal places do I need to go from 4 to 6? That's how many? Right, 2. Now, which direction does my decimal need to go in my coefficient in order for that number right there to increase? Which way? Left. So I need to take this decimal 2 places to the left and temporarily write a new number so that I can add these two together, and then I can put it back in scientific notation. So what's that going to look like? 2 places over is going to give me 0.0448 times 10 to the 6th. You see that? I took the decimal over to the left 2 places. When I take the decimal to the left, my exponent goes up the same amount of places. I took it over 2 places, this goes up 2 places. 10 to the 6th. Now that I've got apples and apples, I can add these two together. So I know that my answer is going to have 10 to the 6th, 5.42 plus 0.0448 gives me 5.4648 times 10 to the 6th. And there you go. That's how you add scientific notation numbers together. Okay, so let's subtract 3.201 times 10 to the first from 2.384 times 10 to the fourth. Now I'm going to treat it like I did with the addition. I need to make these apples and apples. And when I do that, I'm going to take the smaller one and make it like the bigger one. So I've already written the larger one over here, but now I'm going to take the smaller one and convert it so that I can do the subtraction. How many places do I need to move the decimal in my coefficient? Right, 3. Which way? To the left. Okay, so 1, 2, 3 means that my new number is going to read 0.03201 times 10 to the fourth. So I move the decimal over 3 places, and that in turn causes my exponent to go up 3 places, and now I'm ready to subtract. So once I have apples and apples, it's easy enough to subtract this. I get an answer of 2.380799 times 10 to the fourth power. So there you go. That's how we add and subtract numbers that are in scientific notation. Let's do some multiplication and division now. Hey, we'll just use the problem we started with for our multiplication problem, okay? For multiplication, it's actually a little easier because all you do is you multiply your coefficients together and then you add your exponents together. So we have 6.02 times 2, and that gives us 12.04 times 10 to the what? 23 plus minus 23 is 0. However, we still have our decimal in a place that gives us a number that's not between 1 and 10. So what do? We're going to move it 1 place to the left. What happens to our coefficient when we do that? Right, it increases by 1. So we have 1.204 times 10 to the first power. How about if we divide? We have 3.2 times 10 to the fourth divided by 8.0 times 10 to the second. In division, we take these numbers and we divide this by this. And then, as far as the exponents go, we're going to take the difference between those two. All right, so when we divide one coefficient by the other, 3.2 divided by 8 gives us 0.4 times 10 to the exponent. The way we find the exponent is we take the difference. 4 minus 2 gives us 2. But again, we need to make sure that this coefficient is in agreement with scientific notation. So we're going to move the decimal over to the right 1 place. So 4, what does that do to the exponent? We went to the right, didn't we? We went to the right 1 place, left up, right down. So I need to take this exponent and move it down 1 place. So this is going to be 4 times 10 to the first power. So today we learned how to convert numbers into scientific notation. And then we learned about how to add and subtract numbers that are in scientific notation and multiply and divide numbers as well. I hope it's been very helpful to you. If I could be of further assistance, just let me know. Give me an email. Until next time, God bless.